comes to installing your FS230 or FS220 flow meter, you're faced with a number of decisions regarding how to mount your flow sensors. Do I have high precision or universal sensors? Where should I mount the sensors? Should I mount in direct or reflect? What spacing offset should I use? And what's a traverse? Confused? Fear not. In this video, we'll cover these concerns and more by giving you all the information needed to ensure the best possible sensor installation. Let's begin with the sensors themselves. Every sensor is designated by a letter-number combination. The letter represents the physical size of the sensor block. As you can see, high-precision sensors come in sizes from A through D, while universal sensors come in A through E sizes. While high precision and universals share sizes, they are really quite different. For comparison, here is both a C2 high precision sensor and a C2 universal sensor. Again, the C represents the physical block size, and the 2 represents its frequency range. Their labels identify their type, whether the sensor is a universal or a high precision. It also identifies their size. You'll need this info for your flow meter programming. The part number also identifies the sensor type and size. HP and universal sensors are completely different, so you'll want to be sure you've properly identified the type you are using along with the size. High precision sensors are designed for use on steel pipes, though they can also be used on plastic pipe. They are selected based on the pipe's wall thickness. Universal sensors are designed to be used on any pipe material. They're selected based on the pipe's diameter. The FS200 utility program can be used to determine the best type and size sensor for your specific pipe. So what should you consider when selecting a location to install your sensors? There's a few things to note. First, how much straight pipe do you have? You'll also want to note the flow direction, since the flow direction will determine where you will locate your sensors relative to the straight run. You'll also want to look at the piping geometry to determine what piping anomalies are occurring upstream of the straight pipe run. And lastly, the orientation. Is the pipe vertical or horizontal? Straight length of pipe is always the first consideration, as sufficient straight pipe upstream of the flow meter will ensure a symmetrical or fully developed flow profile, providing the best measurement conditions. The flow direction must also be considered for placement of the sensors relative to the straight pipe section, to provide as much upstream straight pipe as possible. But how much straight pipe is sufficient? Well, you may have heard the old industry standard of 10 diameters upstream and 5 downstream, but is that really sufficient? That brings us to piping geometry. In deference to an old TV ad, it's what's up front that counts. Multiple elbows, particularly if they are out of plane, will create swirl conditions that persist much more than 10 diameters. A condition that is also affected by the fluid's viscosity. These effects were documented in studies performed by the NIST and will impact any area averaging flow meter. And of course, there's also pipe orientation. Is the pipe vertical or horizontal? Well, either is okay, so why do I even mention it? There are still considerations. If the pipe is vertical, it is preferred that the flow is upward. Downflowing sections can result in shearing of the flow, creating voids that will interfere with proper measurement. On horizontal pipes, the flow sensors should not be installed on the vertical center line, 12 o'clock or 6 o'clock, where the potential for air or sediment exists. Mounting your transducers on the horizontal center line, or at either the 9 o'clock or 3 o'clock position, will provide the best location on the horizontal pipe and avoid the potential seeing any air which would rise to the top or sediment which will settle to the bottom. The flow sensors can actually be mounted at any angle around the circumference of the pipe as long as you avoid that 12 or 6 o'clock position. If you're installing a dual path system, we generally recommend using the 10 o'clock and 2 o'clock positions. This locates the flow sensors 90 degrees apart, which will provide the best averaging since it cuts the pipe into 4 equal parts. So that brings us to actually installing the sensors. When should you choose direct or reflect? What is the spacing offset? And what is a traverse? The simple answer is, the vast majority of installations should utilize reflect mounting. This method places both sensors on the same side of the pipe. The ultrasonic signal crosses the pipe twice, reflecting off the far pipe wall and thus making 2 traverses across the flow stream. There is also a second type of reflect mounting called 4 traverse. This again places both sensors on the same side of the pipe, but further apart. Now the ultrasonic signal travels across the pipe and back twice, making 4 traverses of the flow stream. 4 traverse mounting is only necessary on very small pipes to gain more separation of the flow sensors, or where increased averaging of the flow stream is needed. Direct mounting places one sensor on either side of the pipe. The ultrasonic signal crosses the pipe once, going directly from one sensor to the other, thus only making 1 traverse. There is also a second method of direct mounting known as 3 traverse. This method is rarely used since we could just use reflect. So which mounting method is better? And why should you choose one over the other? The short answer is reflect mounting is preferred for several reasons. It's more precise, enabling use of a spacer bar with no need to measure the distance between the sensors. Secondly, it's more accurate because it provides better averaging of the flow profile and immunity to non-axial flow conditions, also known as crossflow. Third, it enables auto-zero functionality. And fourth, it's the easiest method of installation. Well, knowing that, where and why would I use direct? Direct mounting is the alternative when the pipe or fluid conditions are marginal, which may degrade the ultrasonic signal amplitude. Such conditions as internal pipe fouling or aerated liquids, or in gas applications where flow velocities are excessive, would be reasons to use direct mount. Only plastic pipe installations require the use of direct mount since plastics do not readily reflect the ultrasonic signal. And what about that spacing offset? There are 3 possible positions for setting the sensor spacing: minimum, nominal, and maximum. These positions are relative to the number of sonic wavelengths along the pipe. The flowmeter will select the theoretical ideal position based on your application programming. It is generally unnecessary to make any changes. If real-world conditions make it necessary to alter the selection, Siemens Tech Support can guide you through the process. To now get down to the nitty-gritty. Let's face it, many flow measurement locations just don't provide sufficient straight piping. So what can you do to mitigate the effects of these locations where the pipe run is limited? First, keep in mind that just because there is limited straight pipe, it doesn't mean your flow meter won't operate. But there are 2 conditions that can degrade flow meter accuracy. The first is the likelihood of a distorted, non-symmetrical flow profile. This will affect proper Reynolds number compensation. And second, the presence of non-axial flow or crossflow can and will produce calibration errors in all area averaging flow meters. So what can you do about it? First, look over your piping layout to see if there is a more suitable location than the one you first chose. One with more straight run or less anomalies on the upstream side. Second, mount your flow sensors in reflect mode, preferably in the plane of the elbow. This will negate crossflow errors because the sonic beam will pass through the flow stream at opposing angles, canceling the error produced by the non-axial flow angle. Third, further improvement of the flow profile averaging can be achieved using dual path measurement, where two pairs of sensors are installed 90 degrees apart for greater averaging of the cross-section of the pipe. This now leaves only the asymmetrical flow profile and its effect on Reynolds number to contend with. This was solved handily many years ago with an algorithm that we developed and patented. This feature, known as the disturbed flow tool, enables the user to program the upstream pipe geometry and the distance of straight run to the sensors. This information is used to calculate the theoretical flow profile and the required Reynolds number correction factor, which is then applied to the flow measurement. There is also a downstream straight run entry, which is useful in bidirectional flow applications. When flow reverses, what was downstream now becomes upstream. Once you've determined the location for your sensor installation, you can prepare the sensors for mounting. Attach one mounting frame to the reference position of the spacer bar and attach the second mounting frame to the number index the meter provided when you programmed it. Strap the frame and bar assembly to the pipe at your chosen location. Next, apply a thin bead of couplant to the sensors and carefully insert them into the frames and up against the cross brace. Tighten the sensors with the overhead bolt and then attach your cables, noting the flow direction. Your sensor mount is now complete and ready for operation. So to summarize what we've covered, choose a location with the best available straight piping. If straight pipe is limited, use the disturbed flow tool you find in the flowmeter menu. Avoid mounting your sensors at either the 12 o'clock or 6 o'clock positions of horizontal pipes. Choose upward flowing sections when installing on vertical pipes. Be sure to program the correct type and size sensor. Use reflect mount whenever possible. Mount the sensors at the spacing index assigned by the flowmeter. And finally, relax. You can do it. But we've got your back if you need assistance. Just call our tech support hotline for expert guidance. Thanks for your attention. This is John Accardo saying bye for now.
Siemens, ingenuity for life.